Welcome to Eduora. This is Dipali, your chemistry teacher. Now students, it's time to solve few questions which are asked in the previous year examinations of JEE, NEET, etc. So let's start with the question answer session. Question is, at 300 Kelvin and 1 atm pressure, 15 ml of gaseous hydrocarbon requires 375 milliliter of air containing 20% oxygen by volume for complete combustion. After combustion, the gases occupies 330 milliliters. Assuming that the water formed is in liquid form and the volumes were measured at the same temperature and pressure, then find out the formula of hydrocarbon. The options given are option A, C4H8, option B, C4H10, option C, C3H6, and option D, C3H8. Now students, in this question we have to find out the formula of hydrocarbon, and the hydrocarbon is undergoing in combustion reaction. So we will write down the equation, that is CXHY, where CXHY is the hydrocarbon plus O2 gives CO2 and H2O. H2O will be in the liquid state. We will balance the equation. X moles of C, so we will get X moles of CO2. Y moles of H, so we will have Y by 2 moles of H2O. At the end, we will balance the oxygen. On product side, we will have 2x moles of oxygen plus Y by 2. So these are the total number of oxygen. If I rearrange the term, then it will be 4x plus Y divided by 4. So total moles of oxygen on product and reactant side are 4x plus Y upon 4 moles of oxygen. So students, this is the balanced chemical equation. Now, we have to find out the moles, or we can say the formula of hydrocarbon. First, we will find out that what is the total volume of the gaseous material present. That is already given, which is equal to 330. But out of which, how much amount is for oxygen, how much amount is for CO2, and how much amount is for hydrocarbon. First, we will concentrate on oxygen. Oxygen present in air is 20%. So students, if 20% is present in 100 amount or the 100 gram or 100 unit of air, then for 375 ml of air, how much amount of oxygen is present? Therefore, 20 divided by 100 multiplied by 375, and answer is 75 milliliters. So students, out of 375, we will have 75 ml of air containing oxygen. Answer is coming out to be 300 ml. So, volume of air is equal to 375 minus 75, which is equal to 300 ml. Now, if I check the total volume of the gaseous component after the combustion, then we have oxygen, CO2 and hydrocarbon. Therefore, the total volume of gases after combustion is volume of CO2 plus volume of air, which is equal to 330 ml. Now, if I check the volume of CO2, which is equal to 330 minus 300, because 300 is volume of air, and answer is coming out to be 30 ml. Now students, 15 ml of gaseous hydrocarbon giving 30 ml of carbon dioxide. Then 1 ml of hydrocarbon will give 30 divided by 15, which is equal to 2 ml of CO2. Now students, we know what is the volume of carbon dioxide. At given constant temperature and pressure, the volume is directly proportional to moles. So, 1 mole of hydrocarbon is equivalent to 2 moles of CO2. So students, X is equal to 2. Therefore, the 4x plus y upon 4 are the moles of oxygen. So, if we will substitute the values, which is equal to 75 upon 15, this answer we are getting. If I substitute the value of x, then my final answer will be equal to y is equal to 12. So, now we know what is the value of x and what is the value of y. We have the general equation for hydrocarbon CXHY. So, it will be C2NH12. This will be my formula of the hydrocarbon. So, students, this is the specific type of the numerical where from the given information and amount of the component, we have to find out the formula of the hydrocarbon, where we have to use the balanced chemical equation and combustion reaction is taking place of hydrocarbon. Let's see the next question, and the question is the ratio of mass percent of carbon and hydrogen and carbon and oxygen of a saturated acyclic organic compound X are 4:1 and 3:4 respectively. Then, the moles of oxygen gas required for complete combustion of 2 moles of organic compound X is. This question was asked in JEE Mains 2020. Now, over here, we have to find out that what will be the amount of oxygen required when we have the mass percent of carbon hydrogen and carbon oxygen. Now, students, if I talk about the mass ratio of carbon hydrogen, it is given 4:1. And this 4:1, if I multiply with 3, it will be 12:3. Similarly, for carbon oxygen ratio is 3:4. Multiply with 3, we will get 12:16. Or if we will multiply with 4, then we will get 12:16. We have to find out the empirical formula. So, we will draw the table. In this table, the first column will contain name of element. Second column will contain the mass. Mass of carbon is 12, hydrogen is 3, and mass of oxygen is 16. Moving on to moles. Moles of carbon is 1, hydrogen is 3, and oxygen is 1. So, if I take the mole ratio, which is equal to, for carbon it is 1, for hydrogen it is 3, and for oxygen it is again 1. Therefore, the empirical formula will be CH3O. Now, over here, if I find out the saturated acyclic material or the compound, so my molecular formula for given compound will be equal to C2H6O2. So, over here we have multiplied the empirical formula with 2. So, this is my compound which is C2H6O2. This compound is undergoing in oxidation, or we can say combustion reaction. Therefore, C2H6O2 plus O2 will give CO2 and H2O. If I check the number of carbon, it are 2. So, 2 CO2 we will get. If I check the hydrogen, it is 6. So, we will get 3 moles of H2O. Moving on to the oxygen. If I check moles of oxygen, then 2 into 2, which is equal to 4, plus this 3 oxygen, which is equal to 7. Now, students, if I have to balance the number of oxygen, out of 7 oxygen, 2 oxygen are already present in hydrocarbon. So, remaining 5 oxygen, therefore, it is written 5/2 oxygen moles. Now, students, if I check the ratio or stoichiometric ratio of given reaction, it is 1:5/2:2:3. So, students, if I consider 2 moles of hydrocarbon, then 1 mole giving or utilizing 5/2 moles of oxygen, then 2 moles of hydrocarbon will form or will require 5 moles of oxygen. So, the number of oxygen required to oxidize 2 moles of the hydrocarbon is equal to 5. Let's see the next question, and your question is, molarity of nitric acid, which is HNO3, in a sample which has density 1.4 gram per ml and the mass percent is 63% is dash. Given information is molar mass of HNO3 is given 63. This question was asked in JEE Mains 2020. Now over here, the molarity of the given compound is we have to find out. Density is given and mass percent is also given. If I check about the mass percent, which is equal to 63, which means that 100 gram of nitric acid solution contains 63 gram of nitric acid by mass. Remaining part will be other quantity or water. So if I find out the number of moles is equal to weight in gram upon molar mass. Molar mass of HNO3 is 63. So weight is 63, molar mass is 63. So number of mole is equal to 1. Now volume of the nitric acid for given solution is, I have to find out, then density is equal to mass upon volume. Therefore, students, volume is equal to mass upon density. Mass, it is given 100 gram. Density is already given in question, it is 1.4. So, the volume is equal to 71.4 milliliters. We have to find out the molarity. Formula of molarity is number of moles of solute divided by volume of solution. And if volume is given in milliliters, then multiply the entire equation with 1000. Number of mole we have calculated, which is equal to 1. Volume of the solution is 71.4. Multiply by 1000. Answer is coming out to be 14 moles or 14 molar. So molarity of the given nitric acid will be equal to 14 molar. Let's see the next question. And the question is, if the value of Avogadro number is 6.023 into 10 raised to 23 moles inverse and the value of Boltzmann constant is 1.380 into 10 raised to minus 23 joule Kelvin inverse, then the number of significant digits in calculated value of universal gas constant is. This question was asked in JEE Advanced 2014. Now over here we have to use the relation between Boltzmann constant, which is K, gas constant, which is R. We know that Boltzmann constant, or we can say the gas constant R, is equal to number of molecules, which is Avogadro's number, multiplied by Boltzmann constant, because Boltzmann constant is equal to R by Na. Therefore, if I substitute the value of Na and Boltzmann constant, we will get the value of R. Value of R is 8.312. Now, in the question it is given that number of significant digits we have to calculate. In the answer, we are getting 8.312. So, significant digits are 8, 3, 1 and 2. Total 4 significant digits are given. So, answer is 4 significant digits. Let's see the next question. The ammonia, which is NH3, released on quantitative reaction of 0.6 gram of urea having the formula NH2CONH2 with sodium hydroxide, that is NaOH, can be neutralized by. Question was asked in JEE Mains 2020. The option of given question are: option A, 200 ml of 0.4 normal HCl. Option B, 200 ml of 0.2 normal HCl. Option C, 100 ml of 0.2 normal HCl. And the last option is 100 ml of 0.1 normal HCl. Now over here we have to find out the amount of HCl which are used to neutralize the mixture of urea, ammonia and NaOH. If I show you the stoichiometric relation, then 1 mole of urea forming 2 moles of NH3. So 1 mole of urea equivalents to 2 moles of NH3. 1 moles means molar mass of urea. So 60 gram of urea is equal to 2 moles of NH3. Now, if I substitute the values, then 0.6 gram of urea will be equal to 2 divided by 60 multiplied with the 0.6. So the amount of ammonia, which is NH3, are equal to 0.02 moles. Now we have to relate ammonia with HCl. Moles of ammonia is equal to moles of HCl. Therefore, moles of HCl will be also equal to 0.02. Normality of HCl will be equal to molarity. So, normality of HCl is equal to 0.2 normal. Therefore, the volume of HCl will be equal to 100 ml of HCl. So, now we have the normality 0.2 and the volume is 100 ml. If I check the options, then in option C we have 100 ml and the normality of HCl is 0.2. So, correct answer is option C. Let's see the next question. And the question is, for a reaction N2 plus 3 moles of H2 gives 2 moles of NH3. Identify dihydrogen, that is H2, as limiting reagent in following reaction mixtures. This question was asked in JEE Mains 2019. The options are option A, 56 gram of N2 and 10 gram of H2. Option B, 35 gram of N2 and 8 gram of H2. Option C, 28 gram of N2 and 6 gram of H2. And the last option is 14 gram of H2 and 4 gram of H2. Now over here we have to find out the limiting reagent and we have to identify the limiting reagent for the given condition. If I calculate, then according to the stoichiometry of balanced chemical equation, we can see that 1 mole of N2 reacting with 3 moles of H2 and forming 2 moles of ammonia. 1 mole of N2 is equal to 28 grams. 3 moles of hydrogen, which means 6 gram. And 1 mole is reacting with 3 moles of hydrogen. Therefore, we can say that 26 or 28 gram of nitrogen is reacting with 3 gram of hydrogen. For 56 gram of nitrogen, how many grams of hydrogen is required? We will do cross multiplication and answer will be equal to 12 grams. So students, the correct answer will be option A, that if we will take 56 gram of nitrogen and 10 gram of hydrogen, then we will get the limiting reagent is hydrogen molecule. So students, this is Dipali Chitroda signing off for the today. Stay connected with EduAura. Thank you.